Number 62, calculate the gauge pressures inside 2 centimeter radius bubbles of water, alcohol, and soapy water. Which liquid forms the most stable bubbles, neglecting any effects of evaporation? All right, so basically when they're talking about gauge pressure, they just mean pressure inside of a certain object. And we're talking about bubbles, so we're talking about spheres. And you have a formula here that relates the pressure inside, meaning the gauge pressure, inside of a spherical object. It's a function of the surface tension and the radius of the sphere, right, of the bubble itself. So here let's just copy down the formula. So pressure inside will be equal to 4 multiplied by the surface tension, all divided by the radius. Now we are asked to find the pressure inside of each. So really, they all have the same radius, right, 2 centimeters up here. The only difference is going to be in terms of the surface tension, right? So we're going to do this basically 3 times, all right? So let's just write it out. Let's do this one for water, okay? So the pressure inside that bubble would be 4 multiplied by the surface tension of water. And I got 3 values to pick here. I'd pick the 20 degrees Celsius one. That's about ambient temperature, so it's the most likely one to use. But if you used another one, can't really say you're wrong. It depends on, the problem doesn't tell us a temperature. So then we have to divide it then by the radius, right? 2 centimeters, but remember we need it in terms of meters. So move that decimal 2 places to the left. So we get 0.02 now. And here we have the pressure inside of a water bubble to be 4 times 0.0728, all divided by 0.02. And here it's about 14.56 or 14.6, and that's in terms of pascals, all right, standard units. So that takes care of the first one. Next one, let's do it in a different color. Here's going to be the pressure, let's say, inside of let's do the alcohol next. So there's going to be 4 times the surface tension of alcohol. And alcohol, by the way, will be ethyl alcohol. I mean, rubbing alcohol is isopropyl alcohol, but I don't see that on your list here, right? No, so let's just use ethyl alcohol. So it's going to be 0.0223, all then divided by the radius again, 0.02. That hasn't changed. And now we just got to throw that into the calculator. Well, don't throw it, type it, all right? So 4 times 0.0223 divided then by 0.02. And here is 4.46, so this is 4.46 pascals. Okay, great. And last but not least, let's do it for the soapy water. I'll do it up here. So this is the pressure now inside the soapy water is going to be 4 multiplied by the surface tension of that. And 0.037, looks like we have the value right from the table. 370, decimals right here. And then divide that now by 0.02. And again, just empty that, enter that into your calculator. So 4 times 0.037 divided by 0.02. And we get 7.4 now. 7.4 pascals. Okay, so these are the values. Then it asks for, which is basically saying which is the most stable. So the most stable bubble, it says neglecting any effects of evaporation. So the most stable bubble here would be the one with the lowest pressure inside, right? And that should kind of make sense. If you have a bubble up here, take a look at the upper left. If you have a bubble and there's a high amount of pressure, okay, there's a high amount of pressure in here, right, pushing against the walls, that sounds like it's going to be a lot less stable to me, right? So the lower the pressure is inside of this bubble, the more stable the bubble will be. Now, that's basically how you find your answer. So the lowest one here is going to be that of alcohol, or ethanol, or ethyl alcohol, tomato. So this would be your answer for alcohol. Neglecting any effects of evaporation, that would be the answer, okay? However, though, right, if you had to choose to blow bubbles, and you're probably not going to get your hands on pure alcohol unless you're, I don't know, doing something strange, you can basically take, right, if you look at the differences between pure water's internal pressure here, or gauge pressure, and soapy water, notice how soapy water has less pressure to it. So it's easier to blow bubbles with soapy water than it is to blow bubbles with regular water, right? Anyway, that's enough for the discussion. Thank you guys so much for tuning in. Appreciate it very much. Hope this helped. Please remember to subscribe. See you next time.